Hi everyone! For this video, we're going to do multiplication of polynomials. So for multiplication of polynomials, all you need to remember is to multiply the coefficients, and for the variables, just apply the basic laws of exponents. So for example, we have 2x times 3x, okay? So just multiply the coefficients, the numerical coefficients. So 2 times 3 is 6. And then the variable x, we apply the first law of exponent. So x times x, we add the exponent. So that's 6x squared. Okay, let's have another example. Say we have 3x y squared times negative 4 x squared y cubed. So again, let's multiply the numerical coefficients. So 3 times negative 4, that's negative 12. And for our first variable, x and x squared, so apply again the first law of exponent. So x times x squared, we add the exponent, it will be x cubed because this one has a 1. And for our y squared and y cubed, so we have y squared times y cubed. Again, applying the law of exponent, so we add the exponent 2 and 3, or indices 2 and 3. So that's 2 plus 3 and 5. So the answer is negative 12x cubed y to the 5th. Let's try this one. Negative 7m squared y cubed times negative 2x y to the 7th power times negative 3x squared y. Okay, let's change this m, sorry about that, to x. Okay, so let's start by multiplying our numerical coefficients. So we have negative 7 times negative 2 times negative 3. So negative 7 times negative 2 is positive 14 times negative 3 is negative 42. Okay. Next, for x, we have x squared times x times another x squared. So that would be x 2 plus 1 plus 2. So to the 5th power. And for the y, we have y cubed times y to the 7th times y to the 1st power. So law of exponent number 1. So we add the exponents of y. 3 plus 7 is 10 plus 1 is 11. So the answer is negative 42 x to the 5th y to the 11th power. Now, what if we have a monomial multiply to a polynomial? So for this example, we have 2a cubed times the binomial 6a minus 7. So in this case, we're going to use the distributive property. So distribute 2a cubed to each term of the binomial. So 2a cubed times 6a plus 2a cubed times negative 7. So let's multiply. 2 times 6 is 12a to the 4th power, because 6a, this a here has 1 exponent. Okay. Plus 2a cubed times negative 7. So plus times negative is negative. So 14a cubed. So this is the answer. Next, let's have 3ab times 2a squared minus 4b plus 6. Okay, so using distributive property, so 3ab times 2a squared plus 3ab times negative 4b, and then the last term plus 3ab times 6. So let's multiply. 3ab times 2a squared is 6a cubed b. Then 3ab times negative 4b will be negative 12ab squared. So we have b to the first, b to the first. And then the last term would be 3ab times 6 is positive 18ab. Okay. Now, what if we have a binomial times another binomial? So let's say we have x plus y times 2x plus 2y. So we will use distributive property. And for other books, we will also use the F.O.I.L method. Okay, so let's use distributive property, meaning to say we're going to distribute each of the first term to the terms in the second binomial. Okay, so this and that. All right, so let's do that. So we have x times 2x, and then we have x times 2y, and then for the second term of the first binomial is y times 2x, and then y times 2y. Okay, so x times 2x is 2x squared, x times 2y is 2xy, y times 2x is 2xy, and y times 2y is 2y squared. And as you can see, these are like terms or similar terms, so we can combine that. So 2xy plus 2xy is 4xy. So therefore, our final answer is 2x squared plus 4xy plus 2y squared. Okay. Now, what is F.O.I.L method? When we say F.O.I.L method, F means first. So first means first terms. So the first terms, meaning to say that's x and 2x. Okay. So this means x times 2x. Okay. O means outside, outer terms. Okay. The outer terms are, okay, I will put it here, will be the x and the 2y because they're outside. All right. Now, I is for inside. Okay. What are the inner terms or inside terms? So those are y and 2x. Okay. And L means last terms. All right. Show it here. So our last terms of each binomial will be the y and the 2y. So as you can see, they're similar to what we just did with just using distributive property. Okay, so x into x into y, y into x, and y into y. The good thing about using FOIL is that you're not forgetting any terms to distribute. I'll discuss more of this FOIL method in another video. Thank you.